to start that photoelectric effect. Photoelectric effect. In the last class, as I discussed about that, what is photoelectric effect? Photoelectric effect. So you have seen in the last class, when a light of suitable wavelength, when a light of suitable wavelength, incident on certain surface, incident on certain metal surface, the electrons are liberated, electrons are ejected from the surface of metal. Surface of metal. You see that here, so there is a, in this statement, so you have to know that when a light of suitable wavelength, I mean that you have to use a particular wavelength for a particular metal surface. Then and then only electrons will going to liberate from the surface of the metal. This process, which is known as the photoelectric effect. When a light of suitable wavelength, is it? So for example, all alkali metals, say for example sodium, potassium, cesium, rubidium, these are all alkali metal families. So for these metals, you have to incident only visible light in order to observe the photoelectron emission, photoelectric emission. I mean that these alkali metals, they are photosensitive only for the visible light, whereas these alkali metals, they are insensitive for ultraviolet rays. Is it? So that's why it's saying that when a light of suitable wavelength incident on certain metal means alkali metals are photosensitive for visible light, whereas the ultraviolet, it is photosensitive, I mean that zinc, manganese, cadmium, they are photosensitive for the UV rays. So that means that different metal photosensitive for different wavelength. Different metals are photosensitive for different wavelength. What do you mean that photosensitive? So the metal which is responding for the light radiation, which is responding means the metal which is able to liberate electron from the surface of the metal after light radiation incident on it, such metals are called as the photosensitive metals. I think that you got a clear picture. So when a light of suitable wavelength incident on a certain metal surfaces, the electrons are ejected means liberates. Liberates means free from the surface of the metal, which is known as the ejection from the surface of the metal. This phenomenon, which is known as the, this phenomena is this effect is known as photoelectric effect. I mean that P effect. I mean that photoelectric effect. Okay. So now the electrons which are liberated from the surface of the metal, which are known as the photoelectrons. You see, here we are using the source is light. So photo is nothing but the light. So because of the light radiation incident on the metal surface, suppose the electrons are liberated, so emitted electrons we are calling that photoelectrons. Is it? What are the photoelectrons? The electrons liberated due to the incident of light radiation, which are known as the photoelectron. So liberated electrons, is it? If these electrons, if you pass it through the external wire or external circuit, they will going to constitute this flow of photoelectrons, which will going to constitute the what? Photoelectric current. Is it? So far we have discussed that what is the photoelectric effect. Is it? Different metals, they are responding for the different wavelength. As I said that all alkali metal, they are photosensitive for the visible light, whereas the zinc, cadmium, manganese, these are the photosensitive for the UV rays. That means that different metals, they are photosensitive for the different light radiations. Is it? So now what are the photoelectrons? The electrons or photoelectrons are the electrons which are liberated due to the light radiation incident on the metal surface. Those electrons we are calling that photoelectrons. Such electrons will pass through the external circuit, which is going to constitute the photoelectric current, which is going to constitute the electric current, which is known as the photoelectric current. So now let us see, would like to discuss about the experimental setup of the who discovered this photoelectric effect. Basically, in 1887, Hertz accidentally discovered this phenomena. Later, that this effect, that photoelectric effect, explained by the Albert Einstein. Is it? So therefore, credit goes to the Albert Einstein to explain the photoelectric effect. Let us see, would like to discuss about what is the experimental setup of the photoelectric effect. Is it? So in order to explain the photoelectric effect, Einstein himself is designed that experimental setup. Based on that experimental setup, he is explained that why the photoelectric effect is taking place. Let us see, would like to discuss about the experimental setup of photoelectric effect. So here, in this so in this you can दूसरा तो पानी को अरे वो फैन ये वो ये तो होगा क्या The schematic diagram of the photoelectric effect can be explained. The schematic diagram of the photoelectric effect can be drawn like this. So this circuit diagram consisted of a glass envelope. It looks like this is a glass envelope. This is a big glass envelope is that. So this evacuated glass envelope So this is a glass envelope. You can say that G envelope, glass envelope. So for this it has a side tube, and that this evacuated a glass envelope attached with the, it has a side tube. So this is a side tube. So enclosed with the quartz window. This is a window through which source of light will going to enter. Is it? This is a quartz window. This is a window, quartz window. This window is made up of quartz. This quartz, it allows only particular light radiations, particular wavelength radiations. Is it? So as I said that this is this experimental setup consisted of a glass envelope. On the one side of the glass envelope, a side glass tube is connected and closed with the quartz window, right? So this inside this evacuated glass tube consisted of two electrodes. One electrode is called as the cathode, another is known as the anode. Say for example, this K represents the cathode. So this cathode, it is an what? Photosensitive metal. What do you mean that photosensitive metal? This cathode, this surface emits light radiations. This surface emits the what? Photoelectron after light radiation incident on it. So therefore, these surfaces we are calling that photosensitive surface. This is a cathode is an what you can say that it is a source of rich source of electron. Otherwise, you can say that it is an emitter. Is it? So, as I said that this glass envelope consisted of two electrodes. One is called as the cathode, another is called as the anode. So this anode we are calling that it is an collector. Whatever the photoelectrons emitted from the cathode, all those electrons, they will go to photoelectrons. They are moving towards the what? Anode. Anode, as I said, it acts as a collector. So now see that. So what you have to do that? It is an impartial circuit. So in order to say that, see this is here you can say that source of light radiation. From the source of light radiation, these are the light radiations or photons. Light radiations after passing through the quartz window, it is going to incident on the cathode. What happened that light radiation, it consists of photon. Is it? Bundle of photons. Each photon, it brings in a definite amount of energy. When the light radiation incident on the cathode, what happened that photon is going to interact. Photon, after incidenting the photon with the cathode, it penetrate or it pass inside the cathode. Inside the cathode, there are some free electrons are there. These free electrons, once they are going to collide with the photons, the photons complete energy will going to absorbed by the electron. As a result, now the electron energy of the photoelectron is going to increases. As a result, these electrons, they are come out from the surface of the metal. When they are come out from the surface of the metal, they will go to what? They will go to assemble very close to the cathode. Is it? So in order to move towards the anode, what happened that in order to move these electrons towards the anode, you require an electric field. That positive